Hi guys, welcome back. Today, we're talking about the crucial parameter in energy storage system, SOC, state of charge. It's not just a number on a screen. It's the key to unlocking the full potential of your battery system. Let's get started. What exactly is SOC? It is the remaining energy that tells you what percentage of energy is left. The formula is straightforward. SOC equal to current capacity divide rated capacity. But keep in mind, the rated capacity is a changeable data that related to SOH. Most of today's systems use LFP battery cells, lithium iron phosphate, which are great for safety. But they have a unique challenge because LFP has an extremely flat voltage plateau between 20% SOC to 80% SOC. So voltage barely change in this range, so SOC estimation becomes really hard. Minor measurement errors will lead to significant inaccuracy in SOC estimation. Then how do we solve this problem? We use a combination of three methods working in harmony. First, Coulomb counting. This method will dynamically track the current over time to estimate the remaining energy. Then, Kalman field. It will eliminate interference from current temperature to reduce SOC error. Finally, OCV correction, open circuit voltage. By letting the battery rest and measuring its voltage, we get a true reference point to calibrate SOC. This combination that keeps a high SOC accuracy over time. Next, and what happens if we get an inaccurate SOC? It starts a dangerous effect that impacts the safety, lifespan, and the profit of the entire investment. Let's break down each of these consequences. The first, safety and lifespan. Every battery has a safe operating range, typically 5% to 95% SOC. If an inaccurate SOC reading makes you think you have more energy than you do, you might discharge too deeply. Or it is think you have less, you may overcharge. This causes rapid degradation and a dangerous condition called lithium plating. This is a leading cause of internal short circuit and thermal runaway. Therefore, getting SOC right is literally a safety issue. Next, let's talk about money. Just imagine 1% error in SOC estimation. It might sound trivial, but for a 100 megawatt-hour system, it means losing millions of kilowatt energy over 10 years and hundreds of thousands of dollars losses. Even worse, imagine failing a great service because your SOC display was wrong. You think you have 50% SOC, but you really have 20% SOC. So you cannot deliver enough energy when needed, lead to a penalty or lose qualification from TSO or DSO. Next point, the bucket effect. It means the weakest cell limits the whole system. You can't use full capacity, so you lose revenue every day. Finally, SOC accuracy affects your day-to-day operations and maintenance. If SOC is always drifting, you will need to perform calibration more often, cost more money. Also, monitoring SOC trends is a key way to spot failing cells early. Without accurate data, will lead to more unexpected failure and higher maintenance costs. So this slide is regarding the solution. How can we manage SOC properly? There are 3 key recommendations. First, always operate within the safe SOC range. For daily use, stick to recommended 5% to 95% window or narrow. For long-term storage, maintain SOC at 25% to 50%. Second, implement a regular calibration schedule, normally monthly calibration. Third, choose a right system design that helps you manage SOC effectively, like use string inverter to manage one battery rack, respectively, and adopt active balancing solutions. So get these 3 things right, you will well on your way to a healthy and profitable system. So to conclude, SOC is a very crucial parameter in energy storage system. Investing in getting SOC right is one of the most important decisions you can make for your energy storage project. Thanks for watching. See you in the next video. Bye bye.